have a problem from GATE 2022 Aerospace Engineering paper, question number 37. And we have been given the question as it's a mathematics problem. The question is we have been given a ODE, ordinary differential equation, that is d square y by dx square minus 2 into dy by dx plus y is equal to 0. And we have also been given the boundary conditions which is at x is equal to 0, y is equal to 0 and the derivative of y is 1, and we just have to find the value of y at x is equal to 1 by 2, right? So we have been given four options: 0, root e by 2, root of e by 2. So the NPTEL reference for this particular question is the course by Professor Jitendra Kumar. The course is Engineering Mathematics 1, and you can also see the course web page here. And the particular video that you want to have a look at is from week number 12 and lecture number 57, which is solution of higher order homogeneous linear equations. So, and you can also see the YouTube link for that particular video. So let's go and solve the problem. Now we have been given the problem. We have been given an ODE. In order to solve this ODE, it is a homogeneous ODE because the right hand side is 0, and also in order to solve this ODE, we will just replace d by dx by d. Okay, so if we just replace d by dx by d, then we'll get d square y minus 2 dy plus y is equal to 0, right? If we just take y as common, plus 1 into y is equal to 0. So then if the y will get cancelled and we just have to find the roots. So if we just find the root, we will get d minus 1 into d minus 1 is equal to 0, right? So the d will become 1 comma 1. So we have two roots. These roots are real and repeater roots, right? So if we have a real and repeater roots, let's say alpha is our root, then our solution will have a is a constant, e power alpha x plus bx e power alpha x. Okay, so this is what we'll have. So if we just take e power alpha x, so we'll get a plus bx, right? This is what our equation is. Here alpha is 1, right? Alpha is equal to 1. Let's just substitute that. We'll get e power x into a plus bx. Okay, so this is one equation that we get. Okay, now let's apply the boundary condition, which is at x is equal to 0, at x is equal to 0, y is equal to 0, right? So if we substitute this, y will become 0 and we will have e power 0 and a plus b into 0, right? So we get e power 0 is 1 and this term will vanish, so which will give us a is equal to 0, right? Now our y equation reduces to e power x b into x, right? Now it reduces to this. Now let's find the derivative of this. So if we find the derivative of this, because we have a boundary condition for the derivative as well, right? So we have two functions of x, we'll use the product rule. So then we'll get e power x plus x e power x. Okay, now we apply the boundary condition x is equal to 0, y dash is equal to 1, right? That is what the boundary condition. So now if we substitute y dash is equal to 1, b into e power 0 plus 0 into e power 0. So this term will get cancelled and we will have b is equal to 1. Now we have a value given and b value also has been found. Now let's substitute in the equation. Then we will get x e power x, right? Now we just have to find the value of y at x is equal to half, right? Let's find that x is equal to half. So x is equal to 1 by 2 e power 1 by 2, right? So e power 1 by 2 can be written as root e, right? So then x is equal to 1 by 2. At x is equal to 1 by 2, the value of y will be root e by 2. Okay. So this is the final answer. Let's go and check whether we have this option. So we have option C as root e by 2, which is the correct option for this question. Okay. So the value of y at x is equal to 1 by 2 is root e by 2, right? So that's all for this question. Thank you.